In this video, I'm going to go over some very basic diode applications. Now, if you've gone through the PowerPoint, you understand the basic concept that if this is our diode here, anode on the left, cathode on the right, that if we have a higher potential voltage on the left compared to the right, and we can exceed the V sub F, which is usually, in most of the cases that we're working with, 0.6 volts or 0.7 volts. If that's the case, then current will flow in this direction. However, if we reverse bias the diode, if we switch those two, then it will basically block the current and prevent it from flowing. So that's kind of the analogy with, in this situation, we're looking kind of like at a switch that's closed that's allowing the current to flow. But if that current was flowing in the opposite direction, the switch would open up. So let's take a look at a couple of very simple applications. Let's say device, electronic device, and it runs on, for example, 9 volts and has positive and negative inputs. So the expected input voltage is 9 volts. But if somebody connected the voltage backwards, it would destroy the device. And this can, be a major problem, especially if it's something that can be plugged in or wired without having some kind of battery clip or something like that. And probably you've experienced this. If you've ever had to actually wire something that has a couple of wires, you hook it up to a power supply, it's easy to mix the two up. So a very simple way to prevent this problem is if we put a diode here on the input to our circuit, and then connect it, for example, to 9 volts, plus and minus. If we have it connected properly, then current will flow through the diode. However, if we switch these terminals and had negative on the top and positive on the bottom, that is called reverse bias, and it would prevent the diode from allowing the current to flow, and it'll block the flow. Now, the only downside with this is that if we do have it connected properly and we have our positive voltage here and our negative here, we will lose a little bit of voltage, maybe 0.6 volts across the diode. In some cases, that's not a problem, but in some cases it is. But for using a diode, which is probably only a few pennies, you could potentially save your product and prevent it from being damaged. So that's one simple application. Let's take a look at another. So let's take a look at another application. Let's say, for example, you've got a refrigerator, portable refrigerator that runs on, let's say, 24 volts. And I'll just call it R in my schematic there. And it has a positive input and a negative input, but the power requirement is 24 volts. And during the day, you want to run this off of a solar battery, but at night, you want to run it off of a regular conventional battery. So, for example, I'm going to show over here, we'll say this is a solar panel that can output at least 24 volts. And we'll have one side connected to ground here, the negative terminal, and the positive over here. So during the day, we could run it like this. Obviously, this wouldn't be a very good system, though, because at night, as the voltage drops on our solar panel, which is nominally rated for 24 volts, as it gets darker, the voltage drops and it would not be able to power it. So the idea is we also have some kind of battery here. And I'll just kind of, instead of drawing the battery symbol, we'll just say a B for battery. And we have the negative terminal connected to ground, and the positive terminal could be connected here. Now, the problem with this scenario, though, is that if our solar panel puts out a voltage higher than 24 volts, and our battery that's rated for 24 volts is connected directly to it, it could try to force current into the battery. And vice versa. If the solar panel is there's less light, it's putting out a lower voltage, the battery could try to push current into the solar panel, which could damage it. So we have to come up with a scenario basically that allows us to run these together, but have a way of switching between them when one voltage is less than the other. And a very simple way we can do this is by taking two diodes like this and connecting them together in this fashion. So in this case, if the voltage on this diode is greater than the voltage on this diode at this point here, it will only allow current to flow through that bottom diode. The reason for that is that, for example, if we have 24 volts here on the input, we'd have 24 minus 0.7 volts, or in that case, 23.3 volts. If we had a 0.6 volt, we'll stick with 0.6. 23.4 volts at this point. There. If our solar battery was only putting out 20 volts, the maximum voltage on the other side of the diode would be around 19.4 volts. Well, if we have 19.4 volts here and 23.4 volts here, it will basically prevent this diode, or I should put the 19.4 on this side, or 20 volts here. If we have 20 volts here, and at this point we have 23.4 volts, that diode is reverse bias. We have a higher voltage on the output than the input. So what does that do? It basically makes the diode open up like an open switch. So all the current then would flow from the battery into the refrigerator. Now let's look at the opposite situation here. Try not to make this too messy. Let's see, for example, our solar panels, and solar panels actually put out, even if they're nominally rated for 24 volts, in maximum sunlight, it might put out something like 28 volts, a higher voltage. But let's say, for example, that the voltage on the solar panel is 25 volts on the output. And if we drop 0.6 volts, we'd have 24.4 volts. But on this side of the diode, on our battery, we'd only have 24 volts. So again, we'd have a higher voltage on the output compared to the input that's reverse bias. That will prevent that diode from allowing it to conduct. And so again, in this case, it's like that diode is opened up and no current can flow through it. Now, if you actually try to design the circuit, it will work, but there's some problems. For example, we probably want to also charge the battery during the day if we have enough current. So in most cases with a system like this, you'd have, instead of just a couple of diodes here, you'd have some kind of control module that actually controls a little bit in a more smarter way which way the current flows. See, call it CM. But the basic concept of having a way of routing two different voltages using diodes will function quite well, and it's used a lot of times in circuits. So those are just a couple of simple applications. We'll, maybe a little bit later in the semester, if we have time, we'll look at some others.